Guys, thank you for coming back to our video series of software engineering. We are going to continue with PERT, Program Evaluation and Review Technique. PERT is a technique that uses optimistic, pessimistic, and realistic time estimate to calculate the expected time for a particular task. This technique helps you obtain a better time estimate when you are uncertain as to how much time a task will require to be completed. The optimistic O, pessimistic P times reflect the minimum and maximum possible period of time of an activity to be completed. And then the realistic time R, or the most likely time, reflect the manager's best guess of the amount of time the activity will require to be completed. So what we are talking about here? What we are talking about here is that PERT takes each individual task and calculate, a better time, estimate for that particular task. So you make calculation task by task, but this involve three different time estimate. The optimistic one, which is the minimum, optimistic O, which is the minimum time. The pessimistic one, which is the maximum time, and then the realistic time, which is the best guess of the analyst, the project manager. You see? So does it? So let's see here. So how do you calculate? The formula is O optimistic plus 4 realistic plus pessimistic divided by 6. So this is called, beta distribution. Beta distribution is different from triangular distribution. So if you have a triangular distribution, you have a triangular distribution. You have O optimistic plus R plus P divided by 3. You see, so this is the triangular distribution. Is a triangular distribution. This triangular distribution. Now, what we are talking about here is beta distribution. With the beta distribution, the realistic, which is the best guess, weighs 4 times the rest. 4 times. So you give it a more weight and you divide by 6. So this is triangular distribution, this is beta distribution. So PERT uses beta distribution. Triangular distribution is just the average. Now beta distribution weighs the realistic estimate 4 times the rest, and you divide everything by 6. So what does it mean here? Estimated time, expected time for the completion of an activity. O, optimistic completion time for an activity. It means optimistic means the minimum time. So you are optimistic that it's going to take less time. Pessimistic, you are pessimistic. So you are not sure. So you think it's going to take more time. But your best guess here, you are confident that it's going to take, a realistic time, which is R. You get? So you make your calculation and you get the result. So what does it happen? How do we do? So let's assume that we have our, you remember our our first diagram. We had these, we have defined our activities here, and then we have time estimate here. But in this time estimate, we are using beta distribution, we're using PERT. We don't only have, we don't have one estimate. We don't have one estimate. Because when you are using critical path, critical path, you only have one estimate. You will say, okay, it is 5, it is 6, it is 6, it is 2, it is 6, it is 5, it is 3, it is 1. You guess. So if it is path, you don't, you don't need optimistic or pessimistic. You don't need optimistic, you don't need this, or you don't need pessimistic. You just put your R, and then you use it in your estimation. But here we add in uncertainty, so we don't know what's going to happen. So PERT allows us to, to deal with uncertainty. So it's a gamble, so we don't really know what's going to happen. So what we do is, instead of saying it is 5 days, we say data collection, we can do that in 5 days. But in the worst case, we can do that in 9 days. But we can also do that in 1 day. We are optimistic that we can do that in 1 day. Design, sprint design, normally is 6 days. What we believe that it is 6 days, but it might take 7 days. We are pessimistic that it might take 7 days. So in the worst case, it will take 7 days, but it can also take 5 days. So we are optimistic that it can take 5 days. Report design will take 6 days, but we are pessimistic. It might delay and take 9 days, or we might also be lucky, it takes 3 days. So you do that for everything, and you apply the formula. So here is the formula. You get that? Now, when you have these, when you apply the formula with this, you have this. 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 And so on. So this is the ET. So it is this that you are going to use in your diagram. So what are you going to do? So when you use PERT, what are you going to do? Let's pick our let's go back to paint. Oops. So I in the screen, I go back to paint and I paste it good. Oh, so let me cut this, create a new one. I don't save it. Okay, so let us remove that. So here we have two different methods. We have the CPM, which uses only the realistic, what you believe, without including uncertainty. So if you use the CPM, what is going to happen? If you use the CPM, what's going to happen is, so here, let's put this. If you use the CPM, you are going to use realistic only. So we are going to say that this is 5. If you use critical path, we are not yet using PERT. So number 1 is 5. The duration is 5. Number 1. So yes, this is 5. Number 2 is 6. Number 3 is also 6. Number 4 is 2. Number 4 is 2. And number 5 is 6. Number 5 is 6. Number 6 is 5. Number 6 is 5. Number 7 is 3. And then here is 1. So what is the critical path? We start here. So this critical path here, 1. We have no choice. So where do we go? We go because both of them are the same. So we go anywhere. But let's better choose the alphabetic order. You get that? We could also go here because they are the same, 6 and 6, but we better choose the alphabetic order. The theory of graph recommends that. Now we go here. You get that? You see? And now where do we go here? Where do we go here? We go here. We could go here. We can go here. You get? But now we have a problem. If we go here, you see, if we go here, you see that we have, this is cumulated. If we accumulate this, this is going to be 8. It's going to be 8. You see that 8 is higher than 6. So instead of going here, normally we go here, but instead of going here, we have to go here, because when you accumulate these two, they are bigger than these. You get that? So we are not going here. So we are not going here. You see? We are not going here. So our critical path is what? Our critical path is 1, 2, 4, 5, 6, 7, and then 8. So how do we calculate? If we are to calculate it, what do we have here, guys? We have one. Sorry, I have 5. What do we take is the duration. So it's why me I like using ABC, like that you have no confusion. So we have 5 plus 6 plus 2 plus 5 plus 3 plus 1 plus 22. So we have 22 days using critical path. Now let's see now what do we get when we use PERT. When we use PERT, instead of using realistic, we use optimistic and pessimistic. With CPM, O and P does not even exist. They are not there. So you just give your best scenario, your best case. Now, with PERT, you add in the notion of optimistic and pessimistic, and then you calculate. So with PERT, what do you use? You use this after calculation. So you are going to have 5 here. Is going to be 5. 2 is going to be 6, 6, no change, 2, and then here is going to be 5.5, 5.5, this is 5, is going to be 5.57, there's a dot here, and then 6 is going to be 5, 6 is going to be 5, 7 is going to be 3, and then 1. Now you will see that you have not changed much. The critical path will still be here. This here. Oh, I'm doing like crazy here. Now we are supposed to go here because this is higher than this, but when you accumulate this one, you see that it's still higher than this. So what do? We go here, and we go here. But you guys see that it's still the same 20, 22. So it has not really changed much. It has not changed much because you still have here, this is 11, these are 13, and then 18, and then 20, 22. It has not changed much, but sometimes it can really change. So the objective here is for you guys to understand the difference. With critical path, you just use the realistic, what you think. But with PERT, you introduce the notion of optimistic and pessimistic, and then you calculate the expected time, and it is what you use. For the diagramming, the finding the critical path, whatever, it is the same. It's the same thing. So there is no difference. So let's finish this estimating section with the Gantt chart. The Gantt chart is very famous. So the Gantt chart, just like you can see, depicts you know, the duration of activities, you see. So it's very useful. For example, here we are going to see that activity A, for example, takes activity A. So let me print screen, and then we go to pen so that I can write, or I can even write on here. There's no big deal. Now guys, you see here, so here we have 0. We have a scale of 2. So from 0 to 2 is 2. Scale of 2, 4, 6, 8, 10, and so on. So this is in terms of weeks. And then here we have activity, different activities here, you see. So we have a graph activity in function of activity in function of the duration, you see. A equal f of d. It means what? It means that the duration you put it in the x. This is the x-axis. This is the x-axis, and activities you put them in the y-axis. But it's up to you. You can also do the other way around. So no one cares. It's still the same. Now, so you see that activity 2, will take 4 weeks. 4 weeks. You see that activity B will be in parallel. Activity A and B will be in parallel. But A takes 4 weeks, but B takes 2 weeks. Now after B, you are going to have D after B. See, after B, just after B, you are going to have D, which is going to take, you see, from here to here is 2, and from here to here is like 3. Going to take 3 weeks. You see, this is taking 3 weeks. You see, now after A, C is going to start. After A, C is going to start. It's going to take 2 plus 2 plus 1. So it's going to take 5 weeks. So this one takes 4 weeks. This one takes 2 weeks. This one takes 3 weeks after B. D takes 3 weeks after B, because we have 2 plus 1. You get that? Approximately 1. So it's going to take 3 weeks, approximately. So it can be 3 point something, 3.2, whatever, but I don't want to enter into those. So just understand that activity A takes 4 weeks, because it takes these 2 plus 2, 4 weeks, and then B starts in parallel with B, but it takes 2 weeks. C will start after A and will take it will take 2 plus 2 plus 1, 5 weeks. D will start after B, is going to take 2 plus 1, 3 weeks. And then E is going to start after C. Is going to take, like 1 plus 2 plus 2 plus 1. Here is going to take 6 weeks, and so it is how you build the Gantt chart, and I said you can put the activities in the x-axis and the duration in the y-axis. The duration can be in weeks, can be in days, can be in years, it's up to you. But generally it is in terms of days or weeks, so it's up to you. Now for the rest, you guys can read. You understand that it was created by Henry Gantt. This is why we call it Gantt chart. Henry Gantt developed this, to track the progression of project. So it's a very useful chart. Originally, it was used in building project construction, but there is no single project actually which does not use the Gantt chart. So it's a very famous chart and very simple one. So guys, this marks the end of our time, or schedule or time estimating. So in the next video, in the next section, we are going to cover cost estimating. So we are going to see techniques for estimating the cost of a software. So I hope you guys have enjoyed the video. So I would like to thank you guys for watching. So I see you in the next video. Bye bye.